In this video we'll look at zeros, roots and factors of a polynomial. Now first, the zero of a polynomial and the roots of a polynomial are essentially the same thing. The difference is that the zero of a polynomial comes from the expression p of x, whereas the roots come from the equation p of x equals 0. Now the roots are in fact the same as solutions. We have solutions to equations. The way I remember it is that solution has two O's and so does roots. Now if you've got the roots or the zeros, then in fact you also have the y-intercepts of the graph of that polynomial function. In our example here, p of x equals this cubic, and we're going to work out p of 2, substitute 2 in for x, and we end up with 2 cubed plus 2 times 2 squared, etc., which becomes 8 plus 8 takes 6, which gives us 0, which tells us that 2 is a zero of the polynomial expression, and it's a root of the equation equal to 0 here. Now the graph of that function would have an x-intercept at 2. Now in this case here we have x take alpha is a linear factor, alpha is a solution, and if that's the case there must be some other factor multiplying with x take alpha, so q of x here, that gives us our polynomial. So these example problems, we have the zeros given to us, and we want to work out all cubics with those zeros. So if I have in the first case zeros of 1 and 4, etc., I know x take 1, x take 4, etc. are my factors. So p of x equals, now we want all cubics, so p of x is a multiple of those three factors, and that multiple can't equal 0. Now the second example, now we have a half as a 0, so x take a half as a factor, and these other factors are conjugate pairs, and they come from a quadratic factor. So rather than doing x take each, we'll use the idea of the sum and product of the zeros. So the zeros, if we were to add them together, that would be the sum of our roots or zeros. We end up with the root 2's cancelling out, and negative 6 is the sum of our zeros. The product, multiply that conjugate pair together, we have difference of 2 squares, so we've got negative 3 squared is 9, and root 2 squared is 2, so 9 take 2 gives us 7 for the product. And therefore we know a quadratic factor will be x squared take the sum, so plus 6x, and then plus the product. So this pair of zeros come from this quadratic factor here. And we get the x take a half for that first 0. So we can write our cubic polynomial, p of x is x take a half multiplied by the quadratic factor. And once again, multiples of a for all quadratics, where a not equal to 0. In this example here we have an equation. We wish to use the sign diagram and the discriminant to work out the values of k for part A to D. So b squared take 4ac is our discriminant. Replace b by k plus 3, a is k. Now c, well, we need to rearrange that equation first to make one side equal to 0. So therefore c equals negative 1, which means in our discriminant we have a plus 4k at the end there. And expand our terms and then collect like terms, and we end up with this quadratic, which can be factorised into two factors, and from those factors we can now work out a sign diagram. So the zeros are negative 9 and 1. Choose a number over here, so 0, plug it in for k in these brackets, and we end up with 9 times by 1, which is a positive value. So on the right-hand side of our sign diagram, we've got a positive, and then we alternate our signs as we have no repeated factors in our quadratic. So there's our sign diagram. So for part A, if we want two distinct real roots, our discriminant must be greater than 0. So on our sign diagram, we want the positive sections only. So we draw empty circles at the zeros and arrows pointing left and right. So that region, we have k is less than -9 or k is greater than -1. Now part B, two real roots. That means we can have two distinct or two repeated roots, which therefore means we have greater than or equal to 0 for our discriminant, which means it's the same result as part A, except our circles are now coloured in, so therefore our expression will have less than or equal to and greater than or equal to. Part C, repeated root, means we have discriminant equal to 0, and that means we are at the solutions of -9 and -1. And the final option, no real roots, means discriminant is less than 0. So on the sign diagram, we want the negative section, so between -9 and -1, but not equal to. So our inequality there, -9 is less than k is less than -1. And that will be our solution to that problem.